Good morning, students. Today, we start new chapter sequence and series. Okay, yesterday I am telling some questions homework. Today it's something grow. Okay, today we start new chapter sequence and series. Okay, weightage for this chapter is 1 marks 1 question. 1 mark 1 question. 3 marks, 2 questions, 6. 3 into 2, 6. Next, 4 mark, 1 question equal to 4. Total 11 marks. This one also important in theory and CET also. In this chapter, you get 1 question in multiple choice. Okay. In case CET or JWS. 1 mark 1, 3 mark 2, 4 mark 1, total 11 marks in this chapter. Okay. Next we'll study sequence and series. Sequence means an ordered set of numbers. An ordered set of numbers. Sequence means an ordered set of numbers. Are the numbers written in a definite order. Definite order. For example, 1, 2, 3, and so on. 2, 4, 6, and so on. Okay, these are the sequence. An ordered set of numbers. Series means the sum of sequence is called series. The sum of sequence is called series. 1 plus 2 plus 3 plus and so on. 2 plus 4 plus 6 plus and so on. This is series. Series means sequence or sum of sequence is called series. Okay, sequence means an ordered set of numbers. First, we have to study sequence. Sequence. The numbers written in a definite order is called sequence. Okay, the numbers written in a definite order is called sequence. Okay, for example, 1, 2, 3, 4, and so on. 2, 4, 6, 8, even natural numbers. The numbers written in a definite order. An ordered set of numbers. An ordered set of numbers. Okay, the sequences following specific patterns are called progressions. Okay, sequences following specific patterns are called progressions. In this sequence, there are 3 types actually. Sequence. Okay. First one, arithmetic progression. Arithmetic progressions. Second one, geometric progressions. Geometric progression. Third one, harmonic progression. Harmonic progression. In this chapter, we have to study arithmetic progression, geometric progression. Harmonic progression is not there in this syllabus. Okay, but this one also important. This one also important in multiple choice questions in CET. This one are important. Harmonic progression. In this syllabus, only we have to study arithmetic progression and geometric progression. Okay, this one also important, but in theory is not there. In CET point of view, Very important, harmonic progression. Okay. In previous class means 10th class. Okay, you have to study about ATOD, arithmetic progression. In 10th class, already you have to study arithmetic progressions. In this chapter, discussing more about AP. In this chapter, discussing more about what? AP, arithmetic progression, geometric progression, arithmetic mean, geometric mean. Next, relationship between AM and GM. AM and GM. In this chapter, we have to study more about AP and AM, GM, geometric mean, relationship between arithmetic mean and geometric mean, and also in series, sum to n terms of special series, sum to n terms of natural numbers, sum to n terms of squares of natural numbers, and sum to n terms of cubes of natural numbers will also study. Okay. For example, 2, 4, 6, 8, and so on 20. 1, 3, 5, 7, and so on 15, and so on 15. These numbers form a sequence. These are the sequence: 2, 4, 6, 8, and so on 20, and so on infinity. Okay, 5, 10, 15, 20, and so on. These are the sequence. Okay, 2, 4, 6, 8, and so on 20, 1, 3, 5, 7, and so on 15. These numbers form a sequence. Okay, the various numbers occurring in a sequence are called terms. The various numbers occurring in a sequence are called terms or elements. Okay, we denote the terms of a sequence by A1, A2, A3, and so on. A1, A2, A3, and so on, AN, etc. Okay, this means what? Terms. These are the terms. This is first term, second term, third term. A1 means what? 2. This time. Okay, the various numbers occurring in a sequence are called terms or elements. We denote the terms of a sequence are denoted by A1, A2, A3, and so on, AN, etc. Okay, the nth term is the number. The nth term is the number. Okay, at the nth position, of the sequence, and is denoted by AN. The nth term of the sequence, nth term is the number. The nth term is the number at the nth position of the sequence and is denoted by A. Okay, the nth term is also called the general term of the sequence. General term of the sequence. General term. Nth term is also known as what? General term. Nth term is also known as what? The nth term is the number. Next is the nth position of the sequence and is denoted by AN or XN or FN or FN. Okay. Called the what? Nth term of the sequence. Nth term of the sequence. The nth term is also called what? The nth term is also called general term of the sequence. General term of the sequence. Next, from the above examples 2, 4, 6, 8, 20. Okay. In this one, A1 equal to what? 4. A1 equal to 2. A2 equal to 4. A3 equal to 6. Next, A4 is equal to 8. And so on. Which term is 20? 10th term. A10 is equal to 20. A10 is equal to 20. These are the terms. These are the what? Terms. 10th term is 20 element. These are the elements. First element, second element, third element. Next 10th element is 20. Next, how to find nth term? Next I will tell you. In the second example, first term is A1. Now, okay, terms are denoted by what? A1, A2, A3, and so on, AN. Okay, and so on, AN. Next, the nth term is the number at the nth position of the sequence is what? And is denoted by AN. Okay, and is denoted by what? AN. The nth term of the sequence also known as general. In the second one is A1 is 1, A2 is 3, A2 is 3. These are the even natural numbers. This means up to 21. Next, A3 is equal to what? 5. Next, A4 is equal to what? Fourth term 7. And so on. Which term is 15? Eighth term is 15. Eighth term is 15. Eighth term is 15. Next, we'll study finite sequence. Finite sequence. Finite sequence. A sequence containing finite number of terms. A sequence containing finite number of terms. Finite number of terms. Finite number of terms is called finite sequence. Finite sequence means what? A sequence containing finite number of terms. This one is what? Finite sequence. Okay, this means fixed number. This means what? Fixed numbers. It contains 8 elements. It contains 10 terms. This means fixed number. That is finite sequence. A sequence containing finite number of terms. For example, this one 1, 2, 3, 4, and so on 25. This is what? Finite. This is what? Finite. Okay. Next, infinite sequence. Infinite sequence. Infinite sequence. A sequence containing infinite number of terms. It is not a finite. It is not a finite. A sequence containing infinite number of terms. Infinite number of terms. Infinite number of terms. This means, for example, 1, 2, 3, 4, and so on. Infinite number of terms is not finite. Is not what? Finite. Okay, infinite sequence in the sense that it never ends. Okay, infinite sequence. Next, for example, you have to consider next sequence of even natural numbers. The sequence what? Even natural numbers are 1, 2, 3, 4, you have to take it. 2, 4, 6, 8, and so on. Okay, how to find nth term? Okay, consider the what? Even natural numbers. Here A1 equal to what? 2. A1 equal to what? 2. A2 equal to 4. A3 equal to 6. A4 equal to 8. Okay, and so on. Now A1 equal to 2 can be written as 2 into 1. Observe that. 2 into 1 is 2. A2 equal to 2 into 2 is 4. 2 into 2, 4. Next, A3 is equal to what? 2 into 3 is 6. 3 into 2, 6. Multiply by 2 only. A4 is equal to 2 into 4. And so on. You have to check it. A25. A25 is equal to what? 50. A25 is what? 50. This means what? 2 into 25. 2 into 25. Okay. Next, A26. 52. 52. 52 can be written as 2 into 26. 2 into 26. And so on. And so on. We see that the sequence nth term, okay, the nth term of this sequence can be written as the nth term in this sequence, the nth term of the sequence, the nth term of the nth term of the nth term of this sequence is this sequence can be written as an is equal to nth term is denoted by what? An or xn or fn. An is equal to, observe that, 2 into 1, 2 into 2, 2 into 3, 2 into 4, 2 into 25, 2 into 26, and so on. This means 2 will be constant. 2 will be constant. Okay, previous one, 1, 2, 3, and so on, n. Nth term is n only, because n equal to 1, 1, n equal to 2, 2, n equal to n replace. N means what? Where n is natural numbers. Where n is what? Natural numbers. n equal to 1, n equal to 2, n equal to next, n equal to 2, n equal to 3, and so on. Nth term is n. Okay, an is equal to 2. 2 will be constant. 2 into 2, 2 into 1, 2 into 2, 2 into 3, 2 into 4, and so on. 2 into 2. Okay, now 1, 2, 3, 4, 5, 6. Next is 25, 26, and so on. This means nth term. Okay, now n is equal to 2n. Nth term of this sequence can be written as what? N equal to 2n, where n is natural numbers. where n is natural numbers. To n. Okay. Next, we will consider sequence of odd natural numbers or natural numbers 1, 3, 5. So find 2n minus 1. 1 can be written as 1 into 1 minus 1 is equal to what? 1. 2 into 1 to 2 minus 1 is 1. Next, 3 can be written as 2 into 2. 2 into 2 minus 1. 4 minus 1, 3. Next, 5 can be written as 2 into 3 minus 1. 6 minus 1, 5. Now 7 can be written as 2 into 4 minus 1. This means minus 1 will be constant, will be constant. 1, 2, 3, 4 and so on. N is equal to 1, 2, 3, so on. The nth term of this sequence is what? An equal to 2n minus 1. A n. Base side an. N. A F n. X n. Okay. Nth term of the sequence of odd natural number is n equal to 2n minus 1, where n is natural. This is second. Third one, for example, 1 square is 1, next 4, 9, 1 square is 1, 2 square is 4, 3 square is 9, next 16 and so on. A1 equal to 1 square is 1. Next, A2 is 2 square is 4. Okay, next A3, 3 square is 9. A4, 4 square is 16 and so on. Observe that nth term of this sequence is, therefore An is equal to, nth term of this sequence is what? 1, 2, 3, 4. Power is 2 as it is. N square. Where n is natural numbers. Where n is natural numbers. Where n is natural numbers. These are the sequence. Next, one definition is there for number. Fibonacci sequence are numbers. Fibonacci numbers are sequence. Okay. A finite sequence, the finite sequence in which an infinite sequence, an infinite sequence in which successive number are formed by, in which successive numbers are formed by adding previous two numbers, adding the two previous numbers, adding the two previous numbers. That is Fibonacci sequence or Fibonacci numbers. An infinite sequence in which successive numbers, successive numbers are formed by adding the two previous number. First number and second number is 1 1. That is 1 comma 1. A1 equal to A2 equal to 2 only. Next, adding previous two number, adding the two previous numbers is called Fibonacci sequence. The sequence are 1 1, next 1 plus 1 2, next 2 plus 1 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5 13, 13 plus 8, 13 plus 8 21, and so on. And so on. These are the Fibonacci sequence, Fibonacci numbers. Next, another one point is there. In the sequence of primes, this means Vibhajya Sankhya, prime numbers. Prime numbers are what? 2, 3, 5, 7, 11, and so on. In the sequence of primes, 2, 3, 5, 7, 11, and so on. We find that nth term of the formula. There is no formula for nth prime. Okay, we find that there is no formula for nth prime. There is no formula for nth prime. Okay, these are the sequence, but there is no formula for nth prime. 2, 3, 5, 7, 11, 13, next 17, next 23. Okay, these are the prime sequence. Next is, tell me this sequence. For example, 1, 3, 6, 7, 9, 11. Next is 12, 13, 17, 19, and so on. These are the sequence or not a sequence? Is not a sequence. For example, in this difference is 2, next difference is 3, next difference is 1, next difference is 2. Is not a sequence. This one is what? Is not a sequence. Not an ordered set of numbers, this one. Okay, actually this one, the numbers written in a definite order. An ordered set of numbers, that is sequence, is not what? An ordered set of numbers. Okay, not a ordered set of numbers, this sequence. Sequence, another definition, actually this one. In view of the above procedure, an infinite sequence means an infinite real numbers, an infinite sequence of real numbers. An infinite sequence of real numbers is known as sequence. An infinite sequence of real numbers is a function. An infinite sequence of real numbers is a function. Is a function whose domain is the whose domain is the set n of natural numbers, and codomain is the set R of real numbers. This is sequence. Okay, an infinite sequence of real numbers is a function whose domain is the set n of natural numbers, and codomain is the set R of real numbers. In our, I'm telling you, we have to study function relations and functions studied in this chapter. We will detail telling domain and codomain. Okay, function means a relation F. This means function. Just I am telling the relation F is said to be a function. Is said to be a function. If every element, a relation F from a set A to a set B is said to be a function. Okay. Now, if every element of set A has one and only one image in set B, that is function, is denoted by F from A to B. The function F from A to B. This function is denoted by what? F from the function F from the set A to the set B. This means F from n tends to R. This one is domain. First element and codomain, whole set B is codomain. Domain is this one. In first elements are domain. Whole set B elements are what? Codomain. In this one, domain N is set of domain. Now R is the what? Codomain. Okay. In detail, I am telling in the chapter relations and functions. Next, we'll tell next series definition. Series. Next series. Series means what? Sum of sequence is called series. Sum of sequence is called series. We have to take like A1, A2, A3. Next we have to take that A1, A2, A3 and so on, A and B a given sequence. Like A1, A2, A3 and so on, AN. Be a given sequence. Be a given sequence. Okay, a given sequence. Actually, common way of telling series is sum of sequence is called series. That A1, these are the sequence. These are what? Sequence. This is what sequence. Then the expression. A1 plus A2 plus A3 plus and so on AN and so on AN and etc. Okay, is called the series. Is called the series associated with the given sequence. Okay, the series is finite or infinite according as the given sequence is finite or infinite. The series is finite or the series is finite. The series is finite or infinite. The series is finite or infinite. Infinite according as the given series is finite or infinite. According as the given sequence is finite or infinite. Infinite. Okay, this is series. A1, A2, A3 or F1, F2. Actually, nth term is what? Fn is equal to F1, F2, F3 and so on Fn. These are the given sequence. X1, X2, X3. That is terms, elements. Okay. See, one note is there. Remark. Less than series. Okay. You know this. Sum A1 plus for A1 plus 2 plus 3 plus and so on plus n, that is series. In that sigma or sum of k equal to 1 to n. 1 to n. A n or x1, xn. Sigma or sum of k equal to 1 to n. The symbol. Okay. Now a1 plus a2 plus a3 plus and so on. K equal to 1 plus. Next k equal to 2. A1 plus a2 plus a3 plus and so on. Last one is what? N. Last plus n. This one. Sigma or sum of that. Okay. Next remark. When the series is used, when the series is used, it refers to the indicated sum. It refers to the indicated terms. It refers to the indicated sum, not to the sum itself. Not to the sum itself. Okay. When the series is used, it refers to the indicated sum, not to the sum itself. For example, 1 plus 2 plus 3 plus 4 plus. This is what? Finite series. This is what? Finite series. 1 plus 2 plus 3 plus and so on. This is what? Infinite series. This sum is what? 1 plus 2 plus 3 plus 4, 3 plus 6, 3 plus 3, say 6 plus 4 is 10. This series is what? 10. Okay. Now this is infinite series. This is totally introduction part, sequence and series. So first we will discuss sequence. Next another, actually in this chapter 11 marks, 1 marks in APR GP. 1 marks question APR GP. 2 marks, 3 mark question, one is AP, one is GP. But 4 marks compulsory in series only. 4 mark question in series only, in part E. 4 marks in part E, 4 marks in series only. Okay. Part A 1 mark, part C 3 marks, 2 questions. In last part E, total actually Two questions. One is 49A, 6 marks. B, 4 marks. Next, 15th question. A is 6 marks. B is 4 marks. Anyone solve? 50 or 49 or 3? Solve anyone. Okay, this total 10 marks. This total 10 marks. Solve anyone. 4 marks in this one, 6 marks. In this 6 marks is what? Trigonometry. This one is what? Series. This one is conic section. This one is derivative. In this one, in B, derivative are series. In this one, derivative are series. But this one is trigonometry questions. This one is conic section question. Okay, in this part E, 4 marks series. Okay, next we will discuss the problems. Next, problems. First one, write in this part, first exercise 9.1, 1 mark question only in this part. Write the first three terms. Write the first three terms in each of the following. In each of the following sequences defined by the following. Defined by the following. Defined by the following. First one, an is equal to 2n plus 5. Second one, an is equal to n minus 3 divided by 4. Okay. Nth term is given. Find out first 3 terms, first 5 terms, first 10 terms. Now what first 3 terms are what? N equal to 1, 2, 3 only. First 3 terms. 1 mark important. 1 mark important. Anyone n is given. N equal to 2n plus 5 or n equal to n minus 3 divided by 4. In 1 mark question important. Solution. Here an is equal to 2n plus 5. First one. An is equal to 2n plus 5. Okay. Now substituting what? First 3 terms. Substituting what? N equal to 1, 2, 3. Okay. Substituting n equal to 1, 2, 3. We get first 3 terms, first 5 terms, n equal to 1, 2, 3, 4, 5. Okay. Now we have to find n equal to 1, a1 equal to find out a2, a3. Okay. Now a1 is equal to n equal to 1 first. Now n equal to 1, a1 equal to 2 into 1 plus 5. 2 into 1, 2 plus 5 is 7. Next, n equal to 2, a2 equal to 2 into 2 plus 5. Next 4 plus 5 is 9. 2 into 2, 4. 4 plus 5. N equal to 3. A3 is equal to what? 2 into n is 3 plus 5. 6 plus 5, 11. These are the terms. First three terms. Therefore, the required terms are Therefore, the required terms are 7, 9 and 11. This is the answer in one mark. This type of question. Second one, try this one. N equal to n minus 3 by 4. N equal to 1. 1 is 1 minus 3 minus 2 by 4. Minus 2 by 4 is what? Minus 1 by 4. Okay. Thank you. Tomorrow we will continue the class.